Another method we can use to solve a system of linear equations is called the addition method. In some books, they also call the addition method the elimination method because along the way, we want to be able to eliminate one of the two variables so that we can focus on just solving for one variable at a time. Here are the 5 steps. Step 1, write both equations in standard form, ax plus by is equal to c. In example 3, I noticed that the first equation is not in standard form yet. For it to be a standard form, the x and y terms have to be on the same side, and then the other side should just be a constant. So I can move 4y over to the left for it to be with the x term. So that will become 5x minus 4y is equal to 6. The second equation is already in standard form, so we can just copy it down. Step 2, multiply one or both equations by non-zero constants to create opposite coefficients for one of the variables. We want to do this so that it can help us eliminate one of the two variables. In some problems, it doesn't make a difference if you want to eliminate the variable x or the variable y. But in some other problems, it might take less steps to eliminate one variable versus the other. In this particular problem, I see no difference in eliminating x or y. So let's just assume that we want to eliminate x. So I want you to focus on the coefficients of the x variable right now. One is 5 and the other one is -3. If we could somehow make them opposite numbers of each other, then we can add them together and eliminate them. So between 5 and -3, you want to find the least common multiple of the two numbers, which is 15. So if I want to make the first number of 15, I would need to multiply 15 by 3. And for it to be valid, I do need to multiply both sides of the equation by 3. Now the second one, I want it to be -15, so it can be the opposite of 15. So I need to multiply by 5, and we'll do that with the other side as well. Now we are going to distribute both equations. So the first equation becomes 15x minus 12y is equal to 18. Second equation becomes -15x plus 35y is equal to 5. Step 3, we want to add the equations from step 2 to eliminate one variable, then solve for the remaining variable. Okay, so let's go ahead and add these equations together. Watch how the x terms will cancel completely, or if you add, you get 0, because 15 and -15 are opposite of each other. While the variable y will add up to something, 35y minus 12y will give you 23y, and then on the other side, 18 plus 5 gives you 23. You then divide both sides by 23, so you can get y by itself. So we just solve for y. Now to solve for x, let's look at step 4. Substitute the known value found in step 3 into one of the original equations to solve for the other variable. So look at the original equations, and you can pick whichever equation you want to work with. Let's say I want to pick the first equation. That is 5x is equal to 4y plus 6. I want to substitute 1 in for y, so I can solve for x. So that's 5x is equal to 4 plus 6, which is 10. And then you divide both sides by 5. 10 divided by 5 gives you 2. As always, please do the check step. The answer for this problem is the order pair 2, 1. If for some reason you decide to eliminate the variable y instead of x, then between -4 and 7, the least common multiple would be 28. So we want one number to be 28 and the other one to be -28. For the first one to be, say, -28, we can multiply both sides of the equations by 7. And then the second one, we can multiply both sides of the equation by +4. That way, when you distribute, the first equation will have -28y, and the second equation will have +28y. And when you add the two equations together, the y variable will be completely eliminated, which will help you solve for the x variable.